In all sample size calculation formula, there is a z value. So here, the most common use p, the z, that will be substituted into that formula for that calculation. The first thing that I like to highlight here is that there is an alpha, beta, which represent, if alpha mostly confidence level, but beta is power. So for the alpha, which is actually the probability, correspond to the standard normal distribution, with correspond to also the z here equal to this. So we will see what's behind this common value, but for this, I just like to introduce these three most common terms about confidence level: alpha, c, power, and beta. So here is the original of everything, which is the normal distribution equation, one of the equations that change the world. And here is a forms of the probability density function. If we substitute any number here with the mu of 1 and the standard deviation of 0, sorry, mu of 0, standard deviation of 1, we will get the probability. This is this standard normal distribution, and then if we integral the area, we will have the table of the probability as appear in most of the statistical textbook. So here is the former lesson of statistics, where the student or the researcher need to use at the back of the textbook of statistics to find the probability using the table's value. For example, here, the value in the table represents the area to the greater side of the z-score, like from here to z. That means if z is 0, if z is 0, this is 1. So from here to this is half of the curve. But if z increase up to here, means from 0 up to here about 3, it's cover almost all, means 1. Then the most common statistics that we use in this session for sample size calculations, we use the z alpha. So that means if we aim for to have in the previous slide that I show you, to have end up with the level of confidence about 95% confidence, we will specify the alpha of 0.05, and the z will be 1.96. This is for two-tailed probability. So let's take a look at this first. Also, it uses the same distributions for the power as well, but rather than to say alpha, we call it beta. We will talk about this later. That means if we aim for the power of 80%, that means 1 minus beta is about 0.8. So what is the z? Is about 0.84, or 90 is about 1.64. So with this is 1.64, but it's only one tail or one-sided. So there are one-sided or two-sided. This is one-sided, so it's correspond to if one-sided mean correspond to only the level of confidence is about 95, right? Because 1 minus 0.05, the 95. How about this? If we substitute one-sided using 1.96, it's 0.025 as the tail probability here, and again 2.58 correspond to this. This is one-sided. You usually use it for the sample size calculations, aiming to get the confidence interval only one limit, not both, not the interval. In some situation, we will consider this one to put into the calculation formula. Now, if two-sided, that means in both tail. So we consider both the negative or positive z, but we use only one z substitute in the formula. So the area beyond z is about 0.05, allow for both ends. So multiply by 2, add the two sides together, it become 0.1. So by this, that means if we use this one for the interval, not only one side, we aim for the confidence level of 90%. And if 1.96, we aim for 95%. And if 2.58 is to be used, that means we aim for the confidence level of 99%. The same principle when we test the hypothesis. We also find the probability using the calculated z and looking for the p here, because test statistics is to estimate the p-value, which is all this. All right. So what does it mean by, for example, here, that means it's 1.64, right? This is 4. This 1.64. This is how to use the table. But nowadays, there are many software that calculate all this. It's very easy to get the probability for nowadays. Okay, so then we try to understand about alpha and beta that appear in most of the sample size calculation formula, as well as the test statistics. So in fact, we have two types of error, and represented by the probability of being error, alpha for the type 1 and beta for type 2. So here is what is the definitions that you can touch. If the truth in the populations is false, that means there is a difference between the two measurements, or there is an association exists. That means false hypothesis. And the true null hypothesis means there is no difference or no association. So this is in the populations or in reality. But when we do a sampling from the population and we calculate statistical test, the results can have two decisions, like reject or not reject. Okay, reject what? We test the statistics against the null hypothesis. If the null hypothesis is false, and if we rejected, that means correctly decision for rejection. If not, that means there is an error called type 1 error. The same thing here. If in reality there is an association, but if we are not reject that, that means we are making a wrong decision, which is type 2 error. So this is the definitions of alpha or beta, but both are the probability of being error in making decisions of rejecting or not rejecting the null hypothesis. It resembles this for type 1 and this for type 2. Okay. In diagnostic test study, where the people proposed some diagnostic tests and to see how the performance it is to calculate for sensitivity, specificity, and using this, just like the same thing here, that you might easy to follow. If the test here is the truth or the gold standard, for example, using the pathological findings, say positive or negative. But if the test results, you can just smelling, for example, and say positive or negative. Here is all possible combinations of that decisions. So that will be wrong if you say positive by smelling, but in fact it is negative. That means it's a wrong testing result or false positive. The test say positive, but actually it's false because actually it's negative. So it's just like a type 1 error. And if you smell and say it's negative, but in fact it's positive, that means you do a wrong, you get a wrong test result again, called false negative, which is similar to type 2 error. Okay. So now I introduce another one. This is about power of statistical test. So in the formula of sample size calculations, we have Z beta. So if you decide beta of equal to 0.2, that means you aim for the power of 80%. All right. So here is the definitions of the power of 1 minus beta. That means you correctly decisions by rejecting the false, meaning that you reject that there is difference or associations exist. So here is a clear definitions for that. The power is the probability that the null hypothesis will be correctly rejected. That is rejected when there is indeed a real difference or real association between the factors and the outcome. Okay, you can follow the details here in this website. Okay, there are 4 things that confusing for people in statistics. Alpha, beta, we have already touched. Now, what is the p-value? It's also the probability, you know. And how about the significance level? Okay, so this is the alpha, and I propose again about the common value, and beta, the common value that substitute in either the formula for sample size calculations or statistical test. Now, introduce another one, the p-value, which is actually the probability of obtaining the effect that observed in the study, or more extreme, if the null hypothesis is of no effect or is actually true. That means, for example, if we test if the green tea can reduce weight, okay, the null hypothesis would be the weight between green tea group and no green tea group is similar or the difference is 0, that means the null hypothesis. The alternative hypothesis means green tea has an effect, or the difference of mean is not equal to 0. Okay, so the p-value is actually the probability of obtaining the mean difference being observed from the study, or more extreme of, for example, the mean difference of 3 kilograms weight reduction. Okay, if the null hypothesis of no effect is actually true, okay, or in other words, I say, if the mean difference is 0, is there a chance or the probability that one study obtaining an effect of 3 kilograms or more extreme? That's the meaning of the p-value here. So you can see now the difference it is. I will summarize later. And the last one, significant level. This usually specified at the method sections of the protocol. You know, it's the probability cut point for rejecting the null hypothesis, given that the null hypothesis of no effect is actually true. That means it's a cut point being chosen in advance before seeing the data. So here are the 4 confusing probability in statistics. So the confidence level, in terms of alpha, confidence level, we specify it when we estimate the size of the effect that would be found in the population using what was found in the sample, okay, or statistical inference from the sample to the population. We specify the probability to get the effect size with this known error. Okay, like 95% means error about 5%, for example. For power, we specify it when we plan for a sample size. You know, so we can see only in the sample size formula. For p-value, we calculate it from the data being obtained from the study sample, and then making decisions about reject or not reject the null hypothesis. You know, this is the results after we obtain the data. And significant level is we chose the level or the cut point before seeing the study, seeing the data. Okay, so here all 3 components are specified before studying the study, but p-value is calculated after completion of the study and making decisions about significance or not significance using this cut point. If the p-value is less than the significant level or cut point being chosen, then we interpret that it's significant. All right. So here is the commonly used confidence interval. Therefore, it's reported as the 95% confidence interval to estimate the effect. And for this is 80% power. It's commonly chosen for sample size calculation. For significant level, the alpha of 0.05 is usually chosen. This corresponding to the confidence level of 95%. So if in case you want to go for the 99% confidence interval, the significant level is 0.01. So the 2 things here usually correspond to each other. Okay, this is the end of sample size determination session. I like to suggest learning resources for the web. This is one of the good resources, the one maintained by Dr. Martin Bland. And there are softwares for sample size calculation you can find in Google, PAS, Query, Epitable, SecTrials, PS, Stata, and many others. Good luck.